A very good morning to all of you. So, today we have come to the last section of electricity and magnetism, and that is electromagnetic waves. So, today what I will do is I will discuss about electromagnetic waves, what do they represent and what are these waves and what kind of frequencies, etc., etc. So, recall we have been discussing the basic equations which describe electricity and magnetism. So, let me write the 4 equations that we have obtained through the course on the lectures on electricity and magnetism, and these are called Maxwell's equations, because Maxwell added a term which I described last time as the displacement current, and that is a very important contribution that predicted the existence of waves which are now called electromagnetic waves. So, let me first write down the Maxwell's equations. So, first of these equations is integral E dot dA charge enclosed by epsilon 0, integral B dot dA is equal to 0, integral E dot dL is equal to minus d by dt of phi b, which is equal to minus d by dt of integral B dot dA, and finally integral B dot dL is equal to mu 0 I plus mu 0 epsilon 0 integral epsilon 0 d by dt of integral E dot dA. The 4 equations in form of integrals, and these are the 4 Maxwell's equations. This is nothing but Gauss's law we have used right in the beginning. This tells me that the flux of electric field must be equal to the charge enclosed by epsilon 0. So, let me draw a figure here. So, if you take a surface like this, then the electric flux which is coming out of this, these are the E fields, this is integral E dot dA is equal to charge enclosed by epsilon 0. So, it says is that the first equation says that the net electric flux coming out from a closed surface, this integral with a closed surface must be equal to the charge enclosed divided by epsilon 0. So, depending on the sign of the charge, the electric flux is pointing away from this surface or towards the surface. So, the charge is positive, then we know the electric flux is coming out. If charge is negative, the electric field lines are entering the volume, entering the surface area. Also note that as we have discussed before, if the net charge inside is 0, the flux is 0, and that does not imply the charges are 0. I could have electric fields with net flux being 0. The second equation, which is in magnetic field, if I take another surface here, then I find that integral B dot dL, B dot dA must be equal to 0. No net flux coming out, because magnetic field lines are closed lines. As many field lines enter the volume as are coming out. So, magnetic field lines are closed lines, and so it also implies that there are no magnetic charges. That means, no points from which magnetic field lines emerge or get converged in. In other words, we say that magnetic monopoles do not exist, and so magnetic field lines, as we have seen before, are always closed lines, and so if you take a closed surface, the net magnetic flux through that surface will be 0. So, this is the second law which we have written. The third law, which is Faraday's law. So, if you take a loop, and if you have magnetic field lines crossing that loop, then this equation says integral E dot dL is equal to minus d phi b by dt.